As we work through our zoo example and writing this animal class, I will refer back to this class diagram quite frequently. I created a project folder called Zoo Example, and we are going to demonstrate using the header files and then a separate implementation file for your class. So the first thing that we're going to do is to set those files up. So we're going to add a header file. Since we are creating the animal class first, it should be named animal.h. And then we are going to add a source file named animal.cpp. And we will add a driver file that will include the main method for our functions or for our project. The name of the class, animal, is going to match, and I needed to choose .cpp there. And then we will have a driver. Because this is going to be for our zoo, I'm going to go ahead and name it zoo driver. And that's just our client program that we're going to work with. Inside of animal.h, we are going to start our header file with #pragma once, and I have filled in some of the code already. I'm going to show that on the screen here. What I've started is I have the 3 instance fields, weight, name, and total food. I have started the default constructor setup and my parameterized constructor, and then we will have what's called a destructor, which starts with the tilde, which is above the tab key, and just the name of the class. And that's all you generally have to do for the deconstructor. Remember, the deconstructor helps take care of memory, and it cleans up memory for us. Because in C++, the memory allocations and such we have to manage versus other languages such as Java where it's cleaned up for us. I also copied over the class diagram, and I'm going to use that as a template. I do that frequently where I copy it over and I paste it in, and then I just use that as my template for the rest of the coding for the header file. So get name, I have to switch this around from the, is going to return a string, and we will make those changes on all of our methods here. I'll pause the screen and make all of those changes sometimes if it takes a little bit of time to clean things up. Our setter methods, remember, are generally void. Our feeding method is not going to return anything. It's just going to control our instance field. And I added a new method. I don't remember if that was in the class diagram or not, called speak. If I take a peek at it, yes, speak is going to be how the animal will speak to us. And then we just clean up the rest of this by putting in semicolons at the end of our header files. On some of these we do have parameters, and that should clean up our header file. And then we will write our implementation file for an animal next. When writing our implementation file, I will often copy over our methods that we're going to have to write. So I'm going to copy everything underneath public. I'm going to copy, go to our animal.cpp, and paste. And that gives me a template for knowing what I need to write as far as the methods. There's going to be several things here that we need to talk about. One is, in order for this to understand or know that it's working with an animal, I need to #include the header file, and that's going to be #include and animal.h. I hit a tab key in order to use the shortcut. And then we're going to have to start to write our methods. Another thing that I have to do in order for the implementation file to know that it's working with the animal class, or to know, for this method to know that it's working with the animal class, we use a scope resolution operator, : to tell it that it's going to find this method animal with this class. And so for every single one of our methods here, I'm going to copy this. We're going to need to add the animal class and the scope resolution operator. The colon is the scope resolution operator. And so that's going to go in front of every method name. On the destructor, I'm not sure of the order. Let's see if I change that around and see if that takes care of the error. It did not. We will come back and take care of that in a little bit. And so in front of every method name, you need to add the name of the class followed by that scope resolution operator whenever you're creating a new class. And I'm just copying and pasting. That's the nice thing about using, if you set up your header file correctly, that's the nice thing about using it as a template here. Now, the other thing is, it's looking for implementation code. So every single one of these semicolons is going to need to be deleted and replaced with beginning ending braces. And so I'm going to do that now. And we will slowly work on getting this code cleaned up. And if you notice, there's one more set of red error messages. And if I hover over it, it says the string is unidentified or undefined. And we should know that because when we work with strings, we normally have to do pound include string. And then we use using namespace standard to know that we're going to be working with a string. If I do that, you can see that the error then disappears. If I uncomment pound include string, it comes back. Likewise, if I comment out using namespace standard, the error still persists. And so we need both of those lines of code in order to get rid of that error. But these two lines of code in a header file are actually poor programming practice, and let me explain. These two lines of code say I'm going to include the using namespace standard, but the namespace standard is a container that is a set of identifiers or symbols. They provide a level of direction for specific identifiers. So it makes it possible to distinguish between identifiers with the same name. But here's the problem. If you have something that's named exactly the same in a different file that's in this project, there might be some collision or there might be some confusion. And so we have to manually link string to the standard template library using std and then the scope resolution operator. So you are telling it what it belongs to, the scope of it. And I got one more down here, and as we do that, then it throws another error, and that's because our header file also needs to be changed. So I'm going to go back to our header file, and our header file, every place I have string, I need to again tell it that I'm going to use the standard template library. And so I have to put std : in front of every instance of string in our header files. And from now on, we will just start to do this automatically in our header files. The last thing, if I comment out pound include string, notice I'm not using the using namespace standard, but if I comment out pound include string, it does throw an error. And so that would be a question we maybe need to talk to our Shazam mentors about. But we want to pound include string. We do not want to use a using namespace standard. But if I put pound include string in the header file, when I put pound include animal.h, it copies all those definitions from the header file. So it copies that over, so I don't need to repeat it here. I delete these two lines of code because we should never use them in a header file. And it looks like this should then be getting pretty close to being set up, and we have our implementation now to finish up our animal class. So our animal.cpp implementation, we have a default constructor, parameterized constructor, and our destructor we don't have to write any code for. And a default constructor we should list and give a value for each of our 3 instance fields. If I come over here and copy the instance fields, that just gives me a reminder of what those instance fields are. It's and so I often will copy them over just like this in order that I can have them handy. And then I'm going to go ahead and assign them. Now for an instance, or for, excuse me, for a default constructor, these are my defaults. So I'm going to say that if there is, basically if I didn't set it, then I'm not going to have any weight. And the name, I'm going to just set no name. That's my default. Then that gives me a clue. If I know that that shows up, that it's running through my default constructor. And total food, I am going to assign a value of 0 here. I can copy those and use those in my parameterized constructor because I'm going to set the same variables there. But in my parameterized constructor, I'm now going to bring in the weight value that was sent in. I'm going to use the name variable that was also passed in, and then still set total food to 0. My destructor has no code. I just have to have the destructor. My getter methods are the easiest to write because they are just returning that data type. And in this example, I'm going to return name. And sometimes I will copy that code and we'll paste it, and then we return weight. And likewise return total food for my getters. Those are about the easiest methods to write, are your getters. Remember to keep using your underscore notation for the class level variables. When I have my setters, they are going to look very similar to my constructor, my parameterized constructor. I do have to pass in or have a parameter here, and then my class level variable, my instance field name, will be assigned name. This is also an example of why you would name the instance fields with an underscore. So I can keep this as a variable name, and it's very obvious to me that I'm assigning it to an instance field when I can use that underscore notation. Underscore weight will be assigned weight. That'll be a variable that I send in, the parameter there. And last but not least, we haven't discussed what the feeding method is going to do or what the speaking method is going to do. And right now, I am going to make up a definition for feeding. That is, when I feed an animal, it is going to take and change its weight by the amount that I fed it. And so we know that that isn't going to be typical. But, and actually I'm going to change this variable to amount fed. So I'm going to take the current weight and amount and add to it the amount fed to the animal. And so, and actually I might just make it amount. I'm just going to add in the amount that we fed to the animal. And so if I feed it 5 pounds of food, the animal is going to gain 5 pounds. Just in order to demonstrate that this method would be working. Now the speak method is a little bit different. Speak, we're going to have to decide because I don't know what the, it's an animal right now. It's not a specific animal, so I don't know what it's going to say. So for right now, because it's a void method, I'm going to use count, and I'm just going to say animal speaks, and indel. And again, we run across this problem. It says count is undefined, but that's because it's in our standard template library. So I use std : and then it should, and the same thing here with indel. So both count and indel are part of that standard template library. And count is part of the pound include iostream. So if I'm going to use that, I have to do pound include iostream here. I thought at one time that I didn't have to include both of those there, but let's see if that cleans it up. And then I'm able to use my count statement. All right, so we've got our our animal set up. I already created a driver, and it's a leftover driver, so we're going to see if it's going to work. We got a few things that we have to maybe straighten up here. So I'm going to create an animal. I'm going to call it Tiger. This one is taking 3 parameters. Our parameters was defined as 2, a name and an initial weight. And then there's a get info method, which is actually going to, looks like get info is going to print out the type of animal it is. And we did not do that right now. We only have our feeding method and we have a speak method. So we're going to use our speak method and our feeding method. And so to show you a couple different ways, and then I'm going to access Tiger. It says animal has no member get total food, and I don't remember what I called that method, so I'm going to use that dot operator. And if I use that dot operator, my IntelliSense should bring up the name of the method, so get total food. So this is my driver. I'm just got a Tiger created. I'm going to run the program. We'll see if it will output what happens when I feed the Tiger 20 pounds of food, and what the Tiger will say if the Tiger speaks. And it will also demonstrate using count within a method within a class versus count from the console. So the animal speaks, that's correct. Total food fed at the zoo today is 0. So something went wrong with our total food. If we go back and look at our feeding routine, if I take a look, I changed the weight, but I did not also alter the total amount of food. So every time I feed an animal, I have to change the total food that the animal consumes. And I could also use the notation plus equals amount here so that the total food amount also changes. Let's rerun the program and see if that works. And the total amount fed at the zoo today is 20 pounds, and we have animal speaks. The only thing I don't have outputted here is now how much the animal weighs. So if we want to test that when we're creating a driver, we probably should. And so total weight for the animal. And then here I'm going to call upon Tiger, and I want to get the Tiger's weight. And I want to do that because I want to make sure that I'm adding the 20 pounds to the weight. So this process of, so we've got total weight is 220, so that checks out. Total food was 20 pounds, and the animal speaks. So we have written our animal class, started with our header file, and had private and public variables there. Private variables and public most of our methods. We learned about using a deconstructor today. We learned about the fact that we should not use using namespace standard in our implementation file. You can Google why you should use standard : instead of a using namespace standard to learn more about that if you want. I'm going to clean up and delete out my instance fields there, so I just have my implementation file, and that should clean things up. And again, on your destructor, you don't need to have any any code there. It just automatically, if you want, it's possible to run the destructor and put in a statement here and just say destructor executed, just to see that it did actually work. And I have to use my standard template here in order to get that to work. We'll try this one more time and see if I hit enter. You barely saw it on the screen, but it did say destructor executed if you go back and look at that really quick. I could put in a pause there so you could actually see it on the screen. Not recommended to do that here, and it's not going to like it because it's a system pause and it's undefined. I don't know what library that is in, so I'm actually not going to do that. If I run it again really fast, as soon as I hit enter, watch the screen and you'll see the destructor ran really quickly. That's a wrap for our animal class. We will continue with the subclasses in the next few videos.